Shotguns are pretty cool weapons. They have bullets or pellets like a normal gun, but instead of just one, they have a spread. And this is a really good gun for a game. However, they're a little bit tricky to implement. In this video, I will try to facilitate your implementation of a shotgun in Roblox Studio. This will be using FastCast, and if you don't know what FastCast is, I already have a tutorial on how to make like a gun, which is just basically like a pistol. And this tutorial goes over all the stuff that we did there briefly, and it also expands on it, talking about the spread, how we can calculate the spread and make it realistic yet also random, and just some extra FastCast stuff. So if you enjoyed this video, make sure to like and subscribe. Make sure to join my Discord server. Link is in the description. Without further ado, let's get started. So I've already created a basic gun model, and you'll notice it has these visual parts, but it also has a part named handle. And it is vital that you have this part. If you want a more in-depth tutorial on how to set up your gun and the handle, go check out my original FastCast tutorial. But I already have my handle set up where the character should be holding it. And now what I want to do is go to the handle, click the plus, and create an attachment. And this attachment is going to be where we want our bullet to fire. So I'm going to move it over to about where the barrel should be. So it looks about right. And that will be where our bullet will fire out. And since that's its function, I'm going to name it fire point. There we go. And now we need to make a bullet model, like a little template that we'll use whenever we need to spawn a bullet. And since we're making a shotgun and pellets are roughly spherical, I'm going to make a sphere. I'm going to give it nice metallic color. I'm just going to make it 0.3 by 0.3 by 0.3. There you go. So it's nice and tiny, and it'll work pretty well when we're shooting it out. You can customize this to whatever you want. And I'm going to name it Pellet, then shove it into server storage. And I'm going to take my model, and we're going to name this gun model. We're going to create a tool at the top, and then we're going to put the gun model inside the tool. But make sure to take your handle out and put it higher up so it looks like this, because the tool needs to have the handle spelled exactly like this right below it. And one other thing we need to do before we continue is weld all of these parts. So highlight all of them in your Explorer, go to Model, Create, Weld, and then if you click Draw on top and Show Welds, you can see that everything is welded up nice and good. This will keep all the parts from falling off. And also, turn Can Collide off, because it's kind of weird having a tool with Can Collide on. This is our tool almost done. Let's move it over into the starter pack so it's easier to debug, and then it'll automatically put it in the player's inventory once they spawn in. And let's name it Shotgun, because that is what we are making. So now let's start populating this tool with some scripts. First off, we need to get FastCast. I have it in my toolbox already, my inventory, so I can find it here somewhere. Also, we're going to want PartCache, so FastCast Redux and PartCache. I will have links to these in the description. Just add them to your library, and then shove them straight into your tool. Or if you're making a game with multiple guns, just put them in like a replicated storage or something so all of your guns can get them. So now we're going to make our local script, and I'm going to name this client, and then we're going to make a server script, and I'm going to name this server, and then we want to make a remote event, and I'm going to name this fire event. So what this is meant to do is we have our client that'll pick up the user input and the mouse position. We'll send it to the server via this fire event, and then the server will actually create the bullets using FastCast and PartCache, and it will shoot them, hit detect, whatever. That's exactly what we want in order for everything to be secure, but also fast. Let's first set up the client script, so I'm going to double click on that, zoom in a little bit, and get rid of this line. And we need to do a few things. So first of all, let's get user input service, because we're definitely going to need that. User input service equals game get service user input service. There we go. And then we want to get our fire event, which will be equal to script dot parent dot fire event. Actually, we need to do a wait for child since we're on the client. So do fire event. There we go. And lastly, we need the camera, and the camera is to get the mouse position. I'll say workspace dot current camera. So what we're gonna do is, usually you'll see like most tutorials are like, oh, let's use the mouse, and technically the mouse still works, like just saying player get mouse, but a better way of getting player input and the recommended way for Roblox is using user input service and the camera to get a unit array. I'll show you how to do that. So we also need to get the tool, so I'm going to say local tool, which will be equal to script.parent. There we go. I know it's kind of redundant here and here, but you can fix that if you want. We need to say tool.activated, so when the tool is clicked or touched or whatever, we need to connect a function, and then inside the function we'll say local pose. This will be a vector2, which will be equal to user input service get mouse location. So let's look at the position of the mouse on the screen in 2D space, and in order to get that into a usable thing in 3D, we need to say local ray equals camera viewport point to ray, and then pose.x pose.y. So what this is doing is it's taking our vector2 position, like it's x and y, it's just splitting it up, and we're taking that point and we're converting it to a ray on the viewport, which is like the player's viewing pane. And so depending on where the camera is, it'll just be a ray pointing in the direction of the mouse, and this will allow us to convert that into a position on the server that we can then cast our bullets to. And in order to get that to the server, we can say fire event fire server. And then on the server side, let's just test everything out. So we're going to say local tool equals script.parent. Just need that. And we're going to say local fire event equals tool.fire event. And then we can just say, just for testing purposes, fire event dot on server event connect a function which will have the parameters of the player and the ray. And we can just say print player.name fired array. There you go. So let's play this, make sure everything works properly. We have our shotgun. We click, it says BRIC fired array. That's perfect. So our way of communication set up, let's go head over back to the server, and let's get some housekeeping done, define some variables, set up the basic FastCast functionality. And if you don't know too much about FastCast, look at my original FastCast gun tutorial. That'll tell you all about it. So we're going to say, first of all, get FastCast by saying local FastCast equals tool dot, or actually require, since it's module script, tool dot FastCast redux. I'm going to say local PartCache equals require, if I could spell it right, tool dot PartCache. And then we can define local caster, which will equal fastcast.new. And let me just separate that. And we can also get our part provider. I'm just going to say provider equals partcache.new. So the partcache.new actually takes a few different things. So let's go define them as well. We need to get the pellet. Local pellet will be equal to game get service server storage dot pellet. Let me just make sure it's named that. Yep, it's named that. There we go. And we also need to get a folder where we'll store all of our bullets, which I'll make right now. So in the workspace, click the plus, create a folder, and I'm just going to name this pellets folder. And I can get that by saying local pellets folder equals workspace dot pellets folder. There we go. And then in our PartCache constructor, we want to send in our pellet, which will be the part that we want to keep cached. And we need the number of things we want any given time. You can do 100, 1,000, whatever you want. For right now, I'm going to do 100. That has worked well in testing. For a bigger game, you'll definitely need like 1,000 or so. And then after that, we can say our folder, which will be the pellets folder. There we go. And now we need to find our cast params, which will be equal to rayCastParams.new. We'll set castParams.filter type equal to enum.rayCastFilterType.blacklist. And then we don't want to set our stuff now with the filter descendant instances. We actually want to make an event to do that. So up here, I'm going to say tool.equipped connect a function, and then we're going to set our castParams.filter descendants instances equal to tool.list of the tool.parent. And the reason we're doing this is so each time the player respawns, it'll update the cast params accordingly. And if you don't know what raycast params are, I made a video about it a while back. I will link that right now. And that is a lot of our infrastructure done. We still got a few more things, most notably our FastCast behavior. So I'm going to say local behavior equals fastcast.new behavior. Then we're going to say behavior dot raycast params will be equal to our cast params, and then behavior dot cosmetic bullet provider. This is the PartCache instance that we made earlier. Will be equal to provider, and then the behavior dot cosmetic bullet container will be equal to our pellets folder. There we go. So that was a lot. Didn't really do much, but trust me, this will be useful down the line when we are making our gun. Now let's start with the actual firing mechanics. So I'm going to get rid of this print statement because that was just for testing, and we need to make a few things. First of all, I need to say if tool.parent is a backpack, then return end. What this does is it stops our function if the tool is in the player's backpack, in which case it should not fire under any circumstance. And then next, we can get our mouse position, and this position will be achieved by making a new function. I'm just gonna make it. We're gonna make it right below here. We'll call this local function get mouse pose. It'll take in a unit ray, which is what we created in our client, like the little unit ray. We send that to the server, and then we'll say local ori, which is origin, and then dir, which is direction, equals unit ray dot origin unit ray dot direction times a certain distance. So I'm going to go define this at the top of our script. We're going to call this local, we're just going to say max dist. Make mine 500. So this is the maximum distance your gun will be able to fire, like in any direction. And 500 is a pretty good number. And we're just going to multiply our direction by max dist. So we have an origin at our unit ray origin, and since it's a unit ray, we need to multiply it by whatever amount. And there you go. And now we can say local result equals workspace raycast ori, ori dir, and then cast params, because we want to keep the cast params ubiquitous throughout everything. And then we need to return result and result.position or ori plus direction. So what this does is we get our raycast result, and if the result exists, so if the result is true, we return the result.position, or if there's no result, we return the origin plus the direction, which will get us to the intended result.position. And the reason we're going through all this hassle and not using the unit ray is it looks a lot more accurate that way, because if you're just using the unit ray, you get stuff that's sort of on target to your mouse, but it's not pinpoint accuracy, and we want a good gun. We want pinpoint accuracy, so that's what you want to do. So then down here, we can say local pose equals get mouse pose for our ray. There we go. So that's our get mouse pose done. Now we need to get our ray direction. So our direction will basically just be our position, so our mouse position, minus whatever little indicator attachment that we made. So in order to get that, let's call our new variable fire point, and this will be equal to tool.handle.fire point, and that's our attachment if you recall. Here you can see it down there. And we want to do fire point.world position down in our direction declaration. And we also want to get the unit of this. So what this does is, a lot of this may seem extra, but trust me, I've tried just using unit ray for my guns, and it does not work whatsoever. You need to get the absolute position of where the mouse is clicking, because it just looks a lot better and is a lot more accurate that way. And what this does is we take the position, we subtract it, so we get the vector in between our muzzle and our muzzle/barrel and the position that we hit, and we get the unit vector, so it's less than 1 in magnitude. And then we need to do a few things with that. So since this is a shotgun, our stuff is going to be a little bit different than a normal FastCast gun. So instead of doing one fire call and like saying cast for fire, we need to do multiple. So I'm going to say for I equals 1, and then let me just say 10 pellets. So we'll have 10 pellets due. Then we'll fire our direction. And we need to implement this fire function, so we will do that right below the get mouse position. So I say local function fire with our direction. There you go. Let's make that function. And then inside this function, we will do a few things. So this will be a little bit different than your normal fire, because as a shotgun has spread and the spread is random, we want to simulate that for each pellet. So I'm going to write some code. You don't have to understand it. I have a nice little infographic that will show you how it all works. So just follow along. So we're going to say local direction cf equals cframe.new vector 3.new, and don't put any parameters, but calling just vector3.new just returns a vector that's 0, 0, 0, and then a second parameter of our C-frame will put in the direction. So we create a new C-frame with an origin of 0 pointing towards our direction, which is a unit vector. And then we want to get our spread direction, and this is basically like the area around our directional CF that we want to cast our ray for our bullet. And this will be C-frame from orientation 0, 0, and then math.random 0, 2, math.pi times 2. And math.pi times 2 is also known as like tau, I think it's pronounced. And all it is like math.pi is a semicircle, math.pi times 2 is an entire circle. And you'll see what that means in just a second. And then below that, we need to say our spread angle is equal to cframe.from orientation. And then we need to do math.rad math.random. And then you want two values here. And I'm also going to define that on top. And one of them is going to be local min spread. And I'm going to set the 1 degree and local max spread. And I'll set this to 4 degrees. So these are degrees, like in normal degrees, not in radians. And they have to be pretty small numbers, or else your spread will just be absolutely crazy. And then down here in our from orientation, we can put inside the math.random, we can put the min spread as the first parameter and the max spread as the second parameter. There we go. And then for the other parameters, for our little from orientation block, we can just set those to 0, and that should work perfectly fine. Then we need to define this is our final direction, and this will actually be a vector 3, and it'll be the directional CF times spread direction times spread angle. And by the way, multiplying all of these, oh, I spelled that wrong. Let me just copy paste that. Multiplying all of these is basically just saying 2 world space, 2 world space. So you notice how all these vectors have like origins of 0, and so this just makes them all relative to each other. And at the very end, make sure to put this after our direction at the very end of the line. We're going to say dot look vector. So this gets the look vector of our entire block. And make sure parentheses are around these first 3 values that are being multiplied together. And then finally, we can call caster fire. And then inside our fire, we can say our fire point dot world position, our direction, and then our velocity. I'm just going to say 100. 100 seems to work fine. Actually, let's just say 1,000. And then we can put our behavior, our cast behavior. There we go. So that's our entire code block done. That should make everything fire properly. Down here, that should work fine. So now, we're not going to put the bullets in just yet, just to make sure everything works. At the top, we're going to call FastCast visualize cast, and we're going to set that equal to true. This is a good debugging value that we can do in order to see our cast without actually making a cosmetic bullet to visualize it. And we just need to make sure everything is working. So let's fire it. There's an error. Unit ray is nil. Let me check the client. That's why I forgot to send in the ray into our fire server event. So make sure you do that. We'll go back in, pull out our gun, we'll fire. And you can see all the bullets went pretty fast. We'll add drop a little bit later. But they're all random, but they're all within a tight cone, a pretty tight cone. And it works pretty well. We can shoot from wherever, even in first person. It looks pretty cool as well. And you can see spread is working. So now let me explain all of the stuff that we just wrote in a more visual form. So this is a visual infographic of what we just wrote. The blue line indicates our directional CF from the origin, right here, all the way to our direction. And, you know, this is relative, like horizontal, but in reality, it could be vertical, could be wherever. And then the first random value we calculate is calculated around this circle right here. So this red circle, the circle is perpendicular to our main CF, our directional CF. And then when we calculate our random value, it's a radian, which is why we use math.pi. And it picks a random point on the circle. And in my example, it picks a point right here. And that's what this little arrow is indicating. And the circle is sort of indicating the angle at which we got this random value. And so from this random value, this is only like the area in which we want to project our random spread. We actually need to calculate the spread. So the extent of this little like brownish arrow and like this arrow down here, these are our min and max respectively. In reality, they will not look like this. Ours are like 1 and 4 would look more like this. But for the sake of this demonstration, it made it a lot easier to draw by doing this. And then in between these two angles, we pick a random value. So this light blue, like turquoise vector, is the actual bullets that will fire out. And each time it makes a random one, so you could have a point down here, and then it would calculate a random spread. So you just gotta split it up into parts. And to be honest, this is not my own code. I got this code from the FastCast debug gun. You can see it here. This is debug gun. It's on the FastCast docs, which I'll link in the description. This has a wealth of code in it. Very, very useful. I used this when I was getting started with FastCast. It has a bunch of examples, and all around, it's just a great little gun. And that's where I got my code for my spread, and it works pretty well. So we are on the home stretch. So first thing we want to do to make our guns a little bit more realistic is add acceleration according to gravity. So right below our behavior, we can say behavior dot acceleration. Let me spell that right. Equals vector3 dot new 0. Then we can put negative workspace dot gravity and then 0. So this will make our bullets have drop according to real life gravity, which is pretty cool. Let's actually test that out real quick, make sure it's working. So we have our shotgun. Yeah, you can see the bullets are arcing. It's pretty cool. And then the next thing we want to do is implement our actual bullet visualizer. So I'm going to set visualize cast to false. You obviously can remove this line if you really wanted to. And then we can go down here and create a caster.length changed event. So caster.length changed, and then our function will take in a few parameters. The first is the active cast. I'm just going to say cast. Then we'll have the last point, the direction, like the ray direction, the displacement, and the segment velocity. We won't really use segment velocity. And then the actual pellet part instance that we will be using. So we want to set our pellet.cframe equal to cframe.new last point. Oh, I turned on caps lock by accident. Last point plus parentheses radar, or direction I should say, times displacement. And then as a second parameter, we can just put in last point. And actually, we should change this to cframe.lookat. So this will basically make a point that is properly centered. We have our last point. We add the direction that we're going times our displacement, which is like the length of the direction. And we have our last point, so it's oriented the right direction. Since it's a sphere, it doesn't matter. But if in case you want a different pellet, this should make the front face point in the right direction. And again, I got this from the debug gun. There's other ways of doing this, but I think this is the best way. So let's test that out real quick. Yeah, there we go. Let's see what we did. So the issue is actually up here. I spelled cosmetic wrong, which is kind of annoying, but you know those errors are going to happen sometimes. So if we were to play this again, this should work properly. And you can see, if they're a little small, the pellets spawn in. You can see they can be pretty collected, or if they're farther out, they are farther apart. And that works great. So our pellets hit, but they don't do any damage, and that's what we're going to do next by implementing caster.rayHit connect a function, and this function will have our active cast, the raycast result, the segment velocity, and the pellet instance once again. So we want to get the character, the supposed character, and we'll do that by saying result.instance find first ancestor, which is a model. And before that, we actually want to check if result.instance, then put n down here, just in case it doesn't exist. The result, the raycast result, that will always exist. It says it in the FastCast docs, but we might not always have an instance. I'm not really sure, but let's not find out. And then below that, we're going to find our humanoid, which will be character, find first child humanoid. Well, we actually need to check if the characters exist, so we'll do character and character, find first child humanoid. So just to make sure that our character has a model and then it has a humanoid, we can say if humanoid, then we will damage the humanoid by saying humanoid take damage, and we'll make him take 10 damage since there's 10 pellets, so if you get a direct hit, it'll do 100 damage. And then after we damage them, we want to get rid of the bullets so they don't stay there because they're anchored and it looks really ugly. And we'll do that by saying provider return part pellet. So we'll get the humanoid, we'll make sure they exist, or if our hit is an actual character, and we'll take damage. And we're not actually checking if they're a player because in case you want to kill NPCs, you don't want to have that restricted to just a player. And so this is all good, but what if we don't hit a humanoid? Now below that we'll say else. If we don't hit a humanoid, let's just wait a second so the bullet stays there to add a little bit to the realism. And we can say provider return part pellet. And we don't have to make a separate thread using delay or spawn or coroutine because we're already creating a separate thread with this event connection. So this should all work out just fine. So in order to test this, I'm going to go to my toolbox. Let's get some nice little drooling zombies. And I'll put a few of them around. And we'll be able to shoot them. So let's go in. Pull out the gun. They're already attacking me. You can see when I shoot them, and if I'm sort of accurate, and if my spread's lucky, I can hit them and kill them. And the gun does work from far away, so like most games have damage reduction on their shotguns, so the further away they are, the less damage they'll do. But honestly, the spread accounts for most of that. But if you really want that, you can obviously add that in yourself. Should be pretty simple. You can just measure the range of the hit. You can see I can kill them pretty easily if my aim's halfway decent, but the shotgun works exactly as intended. So that's about it for this video. I hope you enjoyed, and if you have any questions, I will link the FastCast docs. They are very good, very extensive, in the description. And one thing to learn about this video is look at other people's code if you're struggling. Like the debug gun, that was really good. It helped me with the spread. And when you're dealing with C-frames, just experiment, just fool around with things. Like there's nothing, it's not like you're taking a test and if you get it wrong, then you're screwed. It's code. You can run it as many times as you want. So just play around with it, see what works, and you will be absolutely fine. And if you have any other FastCast tutorials, make sure to put them in the comments down below. If you liked the video, like it. If you really enjoyed it, make sure to subscribe. But other than that, hope you have a nice day, and goodbye. And also make sure to join my Discord server.